Good morning, and welcome to what seems to be only the third day of us working with databases. We've done so much. Well, today is a slower day. You see, you have like two things only because today is one of those days where less is more, right? Because you want to take it slow, especially on this piece right here. So we'll probably just go quickly to this portion right there, introduce a couple of new concepts. We're going to talk about joins, which is a way for you to get data from more than one table. So far, we've been working on a single table. So this is going to bring about a conversation of what, foreign keys are, uh, different kinds of joins. Maybe we even just for the fun of it, go and kind of do some grouping of data, maybe see some kind of aggregation function in there, here and there. But we're going to go through that fairly quickly so that we can concentrate on this portion right here because most of the questions are going to come here. So we want to go slow and steady and make sure that we get everything, all of the concepts at a high level. And we can also have some code that we can refer back later when we forget all of this stuff, because too many moving parts, we're going to forget. So we want to have that code there. So we're going to be building something together, adding some code so that we can test how to work with Connect migrations. All right, thank you for the questions thread, Nathan. Good job. And questions so far. It's probably a good day for us to make a stop here and say anything on your mind for the last, 8 days, 7 or 8 days, or maybe 9 or 10 days since you started working on the back end. Time's up. Okay, let's go to work. All right, so the first thing in here is, turns out that we can actually write queries for more than one table. So let's go into our trusty existing database. I'm going to drop this link on Slack so you can quickly find it. And let's take a look at a couple of tables. I'm just going to click on those links on the right and say, okay, I have customers. Well, that's great. All right, they have a customer ID. I have orders too. Oh, look, the orders have the customer ID right there. And also the orders happen to have order details, and you can find the order ID on those. So that means probably very little for us, but let's say that I was asked by management, they come to me and say, hey, Luis, can I please get a report? I want to see a list of all of our orders. Okay, and I come back to them and I say, oh, that's easy enough. All I have to do is do this, Oh, that wasn't nice. All right, let me get rid of the brackets. We don't need the brackets. Okay, no square brackets. Now we can say select start from orders and run that. Excellent. And I send that to my boss and I get fired. And I'm like, why did I get fired? I gave him the data that he wanted. Do you think this is useful for management? Get a listing like this? Is this useful for you? Well, he did say orders, that's right? He did say that. But then, do you think it would be important for, my boss to know who the actual customer is for this order? It would probably be useful. He probably wants to know who is this number 5 employee, especially if the company is Google. And turns out that Google has more than, 10 employees that he knows, so he doesn't know everybody anymore. Yeah. So Andrew says there is a beautiful rule of thumb there. I'm just gonna copy this into my query there. He says, if you want to keep your job, I'm gonna give you a rule of thumb. Don't make the big boss look things up. Give it to them, right? Be the guy that comes with a little extra. So what I really want to know is, if I'm asking for this, I probably want to know who the customer is. So let's start by figuring out who the customer is. So where's the customer data? Well, it happens to be in the customer's table, and we know there is a customer ID there. Okay. So what I'm going to do is I'm going to write this query thinking that I already have both tables in the same place. As if I can just go in there. Actually, let me duplicate this to show you this, what I'm coming from here. So I'm going to come in here and say, I have these customers, and I have a customer name. I'm going to use this, only the customer name from the customers. And why not include also the, let's say the country. Let's say that I'm going to give you the country also. So let's do that. I'm going to come in here and say I have a customer name and a country in that customer table. So I'm going to assume that I have all the data in a single table. This is where you start, the single table. So I'm going to say from the customers, I want the customer name. And if it makes you feel warm and fuzzy, I'm going to do it like this. Yeah, there you go. Also, I want to see from the customers again. I want to see, and look how I'm dotting into the table name, right? I'm assuming that I already have all that data there. That would be the, I think we said the country, right? Country in there. Also, I want to see from the orders now. From the orders, I want to grab that order ID, just in case we need to search for it. Also from the orders, I would like, not orders, but orders. I also want to grab that, I don't care about the customer ID anymore, I don't know who he is. I have this problem with the employee ID, but we're going to come back to that. And also I want to see the order date as date. And also I have that shipper ID. I'm going to come back to that shipper ID later. From orders. Only that if we do that, my query is going to fail. It's like, I don't know what you're talking about. What are you talking about? This customers thing. I don't have that. Okay. So here we introduce a concept of joins. This link is on Training Kits. So go do a quick look at it. There are many kinds of joins. We're going to show two. The default one, which is the inner join, right? And they have a really cool explanation of this. You have one table and you have this other table on the right. And when you do an inner join, this is what you get. I don't know what this is. Learn more, sponsor Slack. Okay, cool. Bye. So when you do an inner join, what you get is the data where there's common information between the two tables, right? So that means that if I do a join and I bring data from both my customers, this is my customers, and also from my orders, there is a piece of information that you can find in both. Let's see if you can spot it. So I'm gonna duplicate this and grab from here only the orders. Run this. I'm gonna place this. I wish. If this was Windows, this should be so cool because I could just snap it to the right there, and that would be nice. But yeah, it's a Mac. It's the beautiful, beautiful interface of a Mac, so I can't do that because it's beautiful. It's just not useful at all. So yeah, I know. I could pay money and get that same functionality that other operating systems have had for decades, right? But I don't feel like it, so I'm just gonna go through this problem here. And I'm not hating on the Mac. I'm stating the fact that, yeah, window management, it's incredible. It's awesome. Yeah, I'm getting the links of all the apps that could do this for me. Why? When the operating system should be doing it by default. I refuse to. All right, anyway, so I have customers and I have orders. See if you can spot a piece of information that appears in both. At least I don't have a virus. Neither do I have a virus on my Windows computer because I'm not visiting those websites. Yeah, so everybody says customer ID. Excellent, right? So you see this piece of information that is common on both. And we are using that as a way to say this record here on orders is related to the customers through the customer ID. I am establishing that relationship by having a piece of information And if you think of this as a parent child, this would be the parent on the left and this would be the child on the right. So on the child side, you say, I'm going to have a piece of information here so that each record can be tied to a corresponding record on the parent table. Some people call this, master detail, parent child, it doesn't matter. The nomenclature that we use, and nomenclature is good, right? That we use, the point here is that they are related somehow, and it's through a field on the child, this dependent table. So what does that graph means? Well, it means that if there is a record here with an ID that appears on the parent table, that record is going to show up on the results. But what happens if I have, let's say that I have some customers that don't have orders, okay? So in those cases, those records from the customers table, they're not gonna appear when you're doing an inner join. Why? Because there is no other record on this table with that customer ID. So only the records where the value is on both tables will appear. So for instance, if you see this customer ID right here, customer ID 1, and we go in here and say order, let's do it on the same line, order by customer ID. Okay, this is going to be ascending by default, and we run this, we'll see that the first actual customer ID that appears is number 2. That means that in my results, when I join both tables using an inner join, there's not going to be a record with a customer ID 1. Shouldn't be, okay? So let's go try it out. I'm going to say, how do I join those two tables now? And I'm going to get rid of this as because date wants to be like a special keyword. So I'm going to say, hey, I want to take these orders, and the proper way is inner join. You could also say join and defaults to inner join, but we're going to make it explicit here and say inner join on the table orders. Okay? And now you're going to see this. Some people do where, do something like this. Let me show you the bad way, bad panda way of doing this. Order customer, like customers from customers. Orders where, and then they say customer ID equals order. Don't do that, right? The way that databases are implemented, that is really, really inefficient, and it's not the right way of doing joins. So I'm going to show you if you ever see that, customers, comma, like two tables separated by commas, and then a where, stay away, start backing up slowly, really slowly, so that you don't wake up that beast and go into another query, okay? So from customers, inner join, orders, okay? And then the condition is here, on, and I could say customers equals to that's the syntax right there. Okay. Now, let's see if that works first, because I may have a typo there. Oh, it seems like it's working, right? So we got the customer name, the country, the order ID, and the order date. And we got 196 records, right? So basically, we get results based on the number of records that I have here on this side. Now, this is cool and all, but I'm gonna add, instead of having orders like that, I'm gonna say orders dot star. That means this is the information that I'm giving my boss about the customer, but also I'm giving all the information about the orders. And I do that, and then the boss comes back and said, I'd like to know who's the employee that sold this. So your job is to extend this query that you have on screen to include also, let's see what we have as the employee. I think we have the employee name. So let's duplicate this and say, give me everything from employees, run that, and bring me the first name and the last name. That's what I want to see. First name and last name from the employee table instead of giving me that employee ID. Go. Oh, nice. Very nice question. It says, so is the table that comes after from considered the parent table? And the answer to that is no. This right here doesn't specify the hierarchy. The way that the data is defined is what specifies the hierarchy. The fact that you have on the child, on the orders table, you have a reference, like a field that's doing a reference to the primary key on the other table, that makes it the child. So what gives you the hierarchy that where you can identify who is the parent is the one that has the field that you're using to link them as the primary key. So in this, I could have done orders and then integer customers. It doesn't matter at the query level. What matters is that we're using the customer ID, and you ask yourself, where is the customer ID the primary key? That is the parent table. So customers would be the parent table, no matter where you do it, how you do it. Actually, I'm going to do it right here, customers, right? And then do orders here. And still you run it, and you still get the same result, right? Do we have to specify inner join, left join, outer join, left outer join, right joins? If you're only doing inner joins, you could get away with, I think most database management systems support that. You could just say join and it works. It's going to be an inner join by default. It's just good practice, especially as you're learning, to kind of make it clear to yourself that this is an inner join that you're trying to do here. But for all of the other joins, though, other than the inner join, you have to specify what kind of join it is. So just to clarify, did you just say, Luis, bluntly that doing select, star from A, comma, B, comma, C tables where well, let's do only two because we haven't done only two, where A dot ID equals B dot A ID, that is bad. Yes, that's what I said. I'm saying this is not the proper way of doing joins, even though that's going to work. That's probably going to work on, I don't want to say all, but I'm going to say most of the database management engines you run into. I'm just saying if you see this and you're doing a code review on that, tell them, hey, can we rewrite this to use an inner join syntax instead? The internals of how the database is implemented, it may be now that new database management system may take this and just turn it into an inner join so you didn't really have a problem with it. But in the past, though, doing it this way made this a lot more inefficient because this is not what where it's intended for. So, bad panda, don't do it. The training kit challenge to join three tables. Yeah, I mean, it works. I'm just saying move to using inner joins like pronto. That's my recommendation, at least. I may be overreacting a little bit. Yeah, stay away from having, this syntax where you have using this artifact as a way to do joins. That's what I'm recommending. Not gospel, but recommendation. So I'm going to remove this from here because I don't want you to even look at that. We're going to do joins, proper joins. All right, so let me see if I could bring that solution to life here. We could say another inner join. Right? We could do this as many times as we need. Even though when you start writing queries, when you're doing joins for a lot of tables, that's probably telling you, hey, maybe you want to restructure your data models so that you don't have to do as many joins, or maybe you want to run this in a process and have it somewhere else saved up so that you do those reports from there. But that's a different conversation for DBAs, right? DBAs is going to tell you, this is way too much. I'm gonna handle this. But for you, if you're doing 3, even 4 of those, you're okay. So all you have to do is you say, okay, now I have this join when I'm getting together data, bringing data from both customers and orders. Now I want to tie that to the employees. Well, I could say inner join employee. What do we need? Well, we need something that is common to the employee. And by the way, the order that you list this is not important. It could be customers or orders first. It doesn't matter. This is just a condition to know which records should I pull to have in this result set. Okay. So if I do from employees, and I want to tie these employees somehow to the information that I have available on the other 2 tables that I have. I have customers. Do customers have information about the employee? And the answer is apparently not. So we cannot really join it to customers. So maybe it must be to orders instead, because the order has the employee ID. So I know that my employees have an employee ID, and I also know that my orders have an employee ID, so that must be it, right? So I'm going to use that field. I'm going to say from the employees, I'm going to use the employee ID. And I'm going to equal that to orders.employee ID. So that's the thinking that happens. You say, okay, of the data that I have available on the other tables, where can I find something to tie it to this new table that I brought in? And we found it within orders. Okay. So now if we run that, we'll see, oh, wait a minute. We have a typo somewhere in there. Can you see it? Can you see it? Employees. And of course, we're not bringing data from employees. So let's go and bring in the employees first name. I'm going to make it nice. I'm going to be nice. First name. And also the employees last name, right? And then comma, everything for the orders. Here we go. It's looking good. There's the customer name. There's the country, first name, last name. And of course, you can do order bys on that. Pretty nice. You can order it by country. You can order it, and you can have these fields in any order that you want. Okay. And we're getting something that is a little better. And then they come back and say, I also want to know who shipped it. So you could use that shipper ID as a way to tie to the other table, to the shippers table. We're not going to do that because it's just more of the same. You identify, you know that you have something on orders. You tie that to the shippers, and then you say, you know, the shipper ID on the shippers is equal to the shipper ID on the orders, and that's going to bring our results back. How do you like it? Questions? Is that making sense in your head? That's what's important. Cool. So that's the basics of the inner join, okay? So what if the question is, I'm going to drop this. I mean, you already have it there, so no need, but I'm just going to drop it just in case. I'm going to make it a code snippet. Hopefully it detects it, okay? So we come back here and say, what if this is not what I want? I want to see a list of all customers without orders. Let's start first, all customers and order information and information from orders. What I mean by this is Even if a customer, like we know that customer number one doesn't have orders, I still want to see him on the list. And I want to give you a warning. This tool has a side effect where the customer ID is going to show up as null on this query, but is an artifact of the web tool. That's not how a regular client, like if you were doing this on SQLite Studio, that null is not going to be there. It's going to be the actual customer ID. Oh, nice. So wait a minute. Let me see. I have more questions before I address down because that's a cool one. Let's do that. SQL code. Okay. Did my inner join backwards like this? Inner join employees on orders that employee ID equals employee ID. Does that make a difference? Nope. That doesn't make a difference. The order of that condition doesn't make a difference. It's still going to work the same. So if you're selecting columns from multiple tables, does the table to use after from even matter? Yeah, because that's one side of the relationship, right? Whenever you do, if you say select start from, let's say, orders, inner join, customers, okay, and on, and then you have your information on the on, you need this table because this is actually the left side of that relationship. Even though we see it on two lines, if you write it in one liner, you will notice that you have two tables here. You have the orders and the customers, and we're going to use now a left join for this. So the question that you were going to have is, okay, well, who is the left join? Is it the one on the condition? How do I know which one is the left join? Well, the left join happens to be the one on the front because this is the one that shows up, if you do it in one line, to the left of this inner join. Okay? So we're going to do it different this time. We're going to say, actually, I had that query already. Why am I doing this? So let's comment this out. Let's say we have this. We're going to list all of the customers and information from orders. Whether they have orders or not, I don't care. I want to see all of the customers there on that report. Remember that we had 196 records, right? Because we were missing a record for customer ID 1. We know they don't have any orders. We can see also that number 6 doesn't have any orders. And if we could continue to go down, number 12 doesn't have any orders. So there are going to be more records, more than 196, because we're going to have one record for each of the orders, including the customer information. But we are also going to have records for all of the customers that do not appear to have an order in this table. Okay? And then we're going to take advantage now of the next question that says, oh, what if I want to see the first name and the last name together? Kind of what we do in concatenation, see them together as bought by or sold by. What is the name that we want to have on those? The employees. Yeah, on the employees' first name and last name as sold by. Yeah, cool. Let's do both right here, right? So instead of having now I want to join from customers. In this case, I need the order matters now. So I'm going to have my orders be on the right side of this. And the from is going to be from customers because I want to have this customer be the left side of the join. And do left join instead. To make it a little easier to visualize, let's break it out different and say left join this and have my on be on the next line, like so. Okay. So from customers on the left, join orders on the right, on this. And remember, the order of this operation doesn't matter, doesn't really affect anything. Okay, so what happens on the left join? Well, let's see. If I do this, I have something. Oh, employees, yeah. So what do I do now with the employees? Well, let's do an inner join on the employees because we want to illustrate the other example. So once we have all of the customers, we bring the orders for those customers, and for each of those orders, we're joining it to the employees. So we can run that, and we'll see that we still have 196 because of this thing right here. Okay, 213. This is the one that I wanted. Okay, the inner join is killing me because it was killing my left join on top. And again, in the join between the orders and the employees, who's on the left? Who would be on the left? It could be orders. Yeah, it should be orders because this shows up first, and then after the join, this is the guy on the right for that other relationship right there. Good job. So I said you will find some nulls in here, but that's an artifact in some cases. Like for the let me bring in the customer ID. We're not bringing it in. Customers that customer ID, right? Run that. This is an artifact of this web tool. That's not really what would happen. What would happen is you get all the information from the customer. I don't know why they haven't fixed that. Okay. And this happens the same. Oh, you remember that we identified that number 6 also had no orders? There it goes, number 6. This would be number 6. So that's what a left join is. So how can I make those two right here? There are some SQLite functions, right? And anytime, right tutorial now, core functions on SQLite. Coalesce is one that's interesting. We should probably mention this one because this is pretty useful. But you will notice that, like, if you go to other databases, you'll find that there are a lot of functions that are not here, like concat. There is a concat that you can use. SQLite doesn't have it. So the way we're going to do this, we're going to do string concatenation to get the results. So we'll say employee, where's my employee? Right here. Employee first name. Instead of comma, I'm going to use this. And then an empty string in the middle, and then that. And then I'm going to give it this an alias as sold by. Okay. It makes me feel good when I have operations like this in parentheses to do the grouping. Make sure that, hey, I want you to calculate this and then give it an alias. Okay. Running this would say sold by Robert King, Janet Lever. Make it bigger so you see that the spaces should be actually there. There it is. So that would be the question asked by Randy. This character right here might be different on other database management system. Another database management system, maybe an equal, like you used to. SQLite, though, uses this. If you go to T-SQL from Microsoft, there is a concat. There's a concatenate string. Is this on SQL Server? Yeah. So you have this concat function on SQL Server. It's different, right? And then you have other ways of doing the same thing. Back concat is probably what you would use if you were using Microsoft SQL Server, but unfortunately, SQLite doesn't have it. Am I missing any questions? The syntax just seems weird to me, selecting columns from employees, customers, and orders from orders. I now see that it's the left table, just how the line, oh, okay, cool. It was confusing before. Normally you will find this be on a different line though. It will probably be like this. But as you're learning it, it makes sense to kind of see who's on the left and who's on the right. It is something that you have to get used to, thinking this way for the joins, but you will get used to it pretty quickly. So let's see if I could save some space here. Now that you know that this is the left table, the outer left table, maybe you get used to the syntax. Now, you remember that we can use aliases for the fields. You remember that? Like this, right? As something that you will normally see is that people do this as C, and then on orders, you say as O, and on employees as E. And if you have something else like order details, it would be like as OD for order details, because that means that I can now take this and make it C instead, and this would be O. Okay, and this would be O to make it simpler to write. Instead of having to write the big name all the time, you could do this. Don't let that confuse you. This is hard. It's for sure hard to read because this is the first time. It's the first exposure. It will get easier. Trust me. You will get used to it. If you even have to write SQL in your job, you will get used to it. What I want to tell you is don't get discouraged because the syntax is kind of strange in the beginning. Once you write this a few times, you'll get used to it. Okay, so what if I wanted to see a list of orders? I don't care about employees anymore. Let me drop this now with a new, using the aliases. From now on, I'm just gonna write using aliases, right? So let's go write another query. And then this time, I wanna see all orders, including the order details. Okay, simple query, similar to what we do. So I'm gonna have you do that, and I'm gonna give you, I don't know, 30 minutes. Let's go work on this. It should be fast. If not, I'm gonna give you the solution here. So your job is all the orders, including the order details. That's it. It's strange to see the alias definition later in the query. Yeah. Let's practice a little more. Get the hang of it. All orders, including the order details. All right, hopefully we have a solution. One way of doing this are, of course, different ways of doing the same thing. I want to see the orders, so I'm going to start from orders O or as O, and then inner join, because in this case, I care only, you know, in this case, it should be okay, but because every order should have order details, but I don't have anything. I don't want to see any empty orders with no details, just the ones that have details. Inner join order details as OD on order dot order ID equals to my order detail order ID. That should give me the results that I want. Not too helpful, but it's giving me some results. Was that hard? Did everybody get it? Okay, what if I wanted to see a list of all the orders with the number of items per order, okay? And actually from the orders, I wanna see all the orders, but only the order, let's say the order ID to make it simpler. But I wanna see the number of items on that particular order. Sounds useful, right? Something that you would wanna know. Maybe not, but let's assume that it's useful. So this is a new concept for you. Now we need a way to count all of the items for the order and then give that some kind of name and provide that as part of the result. But also we want to see the order only once. In this case, if we have, let's do an order by here. Order by order dot order ID. If we run that, we'll notice that we may have more than one record per order. We don't care. I just want to say, hey, 10 to 48 has 3 because it's got 3 lines in it. So for this, we're going to use aggregation. And there are different functions for aggregation. Like average, SQLite is a little more limited because it was designed to run on mobile phones and devices, right? So they sacrifice some things. So some of the functions that you will find, like standard deviation and all of those things, may not be here, right? They may not have it. But trust me, on aggregations, I would like to say SQLite aggregation functions, but in this case, we do know of a function that we can use to count records. You remember that? How to count records? Yeah, we could use the count function. We have that in SQLite, of course. So what I want to do is something like, I want to have the order ID. And also, I want to have a count as, I don't know, items order, maybe number of items order, okay? That's what I want to have. But this is a group. This is a function now that I want to do on the orders. We don't need we do have the order details, but I'm not sure how to do that. I don't know. I'm not sure how can I kind of keep this and just have one value. So what I'm really trying to do is I want to group this by order. Okay, and this is where you bring, whenever you're using something like this, I have a field now. Remember, we use this with count on a single table. Now we have more than one table, and we say, I want to bring this information for the orders, and then a count from, you could think of it as something like this. From the order details, I want to count that. Only the order details for each order. For that, we're going to bring a group by. And here I say, I want to group by order that order ID, which is the actual field. You can also, remember that we could do this order by 1, 2, 3. You could do the ordinal of the fields too. So they would be order by 1 would work the same. It's the same thing. We have a problem here in this thing. I don't like the alias in there. Again, depending on the tooling you're using, you could get away with some things. Here is a little more, yeah. So you remember that first order, 10 to 48, had in fact 3 items only, right? So this is working. It's doing the right thing. I'm saying I want to group this so that my order ID appears only once. And then all of the records that I had that order ID, I want you to group them and count them for me. So you see now the order of operations, right? I have the select, the from, I group them first, and then I order them. What if I only care about particular orders? Let's say with the order ID is, less than 10 to 5A, like the first group there. Or maybe I want to order by, instead of ordering by this, I want to say which orders are the biggest. Let's do that. Let's say order, instead of order ID, I'm going to say by order by this right here. Let me see if this supports it. Not all tools support using the alias there. So I don't know if this is going to work. And say descending. Let's see if that works. It worked. So the tool supported. Very nice. So now this is ordering this result, showing me at the top the orders with the biggest number of items ordered, which is awesome, right? Because I could say, if I do that, I could now say, how about I only want to see the top 15 orders based on the number of items ordered. I could do that. Do you know how can I limit this to grab only the first 10 records of that result? Anybody knows? Limit. Yes, I could call limit. Limit to 10. You saw that when we're doing paging on the other example. So this is the SQL equivalent of that. So now this is a good way to get the top customers. What if I want to do this? I want to see this, but what I really want to see is, I'm going to give you an exercise now to practice this. First, I'm going to give you this code, right? You're going to use this as a base. I'm going to give you 5 minutes to do that one. So I'm dropping this here. You're going to do a combination of both. All right. So I want to see, hey, Luis, hey, Jamie, can I get a list of our top selling products? And I want to be the top 5 selling products. How can you give me that report? Include the product name and the number of items sold of that. Sounds like a useful report. And here, my timer is reminding me of something. Let's take a break. Let's take a 5-minute break. Okay. And then when we come back, we start working on that exercise. So first the break, then we come back and do the timer for the exercise. So I'll see you in 5. And we're back. Please take 5 minutes to write that query, and then we'll see a solution in about 5 minutes. And if you have any more questions, please drop them there. Again, we're looking for the top 5 selling products. We want to see the product name and the number of items sold for that product. Explore the tables, see where you can find those relationships. Escalated quickly. I want to ask for a favor. Hopefully I can count on you. Please do me the kindness of trying to come up with a solution for the exercises. The reason I ask is because I've been, as a student, sometimes I feel like I'm not getting this. I don't even know where to start. And I know that the instructor is going to come back in 5 minutes and give me the solution. I'll wait and just look at the solution. But in the process of trying to come up with a solution, there is a lot of learning that happens. So don't follow the line of least resistance. Do it as a favor to me, right? See if you can figure it out. Do an effort, even if it feels like really foreign to try to think this way. Remember that the thinking here is in sets, so it's kind of weird from what we're used to. But please, please, please try to come up with an answer. Do not bang out your head into the wall. Just make sure that you're typing something, have some motion in it. Okay, let me at least look what information can I relate for this if I don't know how to do the actual top 5. The description of the task again, for sure. Top 5 selling products, include the product name and the number of items sold for that product. I guess I could have written better. Yeah, it is tricky for sure. Okay, we have a few seconds left, so I guess I can start working on this. So again, there may be, who knows how many solutions are for this, So let's see if we can build it step by step. And this is I have a lot more that I want to share with you, but we're gonna stop here because I want to move into the migrations and talk about migrations so that you could work on the exercise for today. Okay. All right, so I want top 5. So I know that somewhere in there I want to have a limit of 5. For sure, that's the first thing. That's a given. I have a limit of 5, only 5. And I want to know, I want the top selling products. So I know that I'm going to order by that and the number of items sold. So I'm going to say order by sold, right? I'm going to call it sold. And this is going to be descending. So now I solve this problem, top 5, and I solve the problem that is going to be organized by the number of items sold for that product. Now I just need to come up with a formula to get that sold thing, right? And I need to figure out, so where's that sold coming from? Well, sold is going to be probably the count, like we did before, as sold. So, cool. So now I know a way to get the sold. The question is, which tables? And I also know that I want the product name. So I'm going to say, I know that I have a select from something, and it's going to have an inner join with something, right? We'll figure that one out. And I know that I want the product name. So if I want the product name, where's the product name? Oh, in the products table. So I have part of it now. I can say P product name. Actually, I need to make sure that, products have that. So let's do this. Say, let me look at the products and I have the product name. Yes, that's good. So I have the product name now. And also I see that I can have a product ID, right? So P product name, that means that I need products as P. Now I know how to get the product name and I need to count something. The something is what's going to be here. So the question is, if I'm looking at orders and I go check the orders, do I have the product on the order? And apparently not. Because actually the product is part of the item that was ordered. So the details for the order happen to have the product ID. Now I can tie this. I could say order details is tied to products using the product ID. So let me go and do that and say inner join order details as OD on a P having a product ID that is equal to the order details that product ID. Okay? So I grab the product name from the product table. I count the rest, and the rest is coming from this other table right here called order details. And then I want to organize this by this sold thing that I created up here. Okay? And there's something else though. Okay, this is cool, it's organizing, but I don't want to see all of the lines for the product names. I want those grouped. I want to see the product name only once and then the counts. So whenever you're looking at aggregates like that with more than just the count or just the average, that means that you have another column here. You need to do some kind of aggregation, right? So aggregation means I want to group things. So how do I want to group that? Well, the product name is a good place to group that. So what do? We say, do all that, and then I want to group by the P dot product name. And to show you, you could do this, group by one, like the first field, if you want to. Run that, and this is what we get. These are the top 5 selling products according to the data that I have here. Cool. I don't even want to ask what this is or how to pronounce it. Cool. Questions, right? So let me drop this there. Again, there's probably other ways of writing this same query, maybe even more efficiently, but this is a quick way, right, of writing it using the stuff that we already know. I like to see that. There's a comment on Slack that says, I got something, but it was the wrong data. Like it gave me the wrong results. That's what I want to see. I want to see, hey, I tried it and I came up with something, it didn't work, or I got an error. I don't know why I get the error, but I want to see that effort. So good job. That's great work. And the process that we used to build this, it was kind of weird because we came like from just all over the place in the description. I'm just trying to show you that you could tackle one thing at a time and then figure out the rest slowly. So there's a question here. Oh yeah, what about the quantity? But that's the quantity, right? That's the quantity that we sold because we're counting them. Maybe you want to see something a little more complex. You're talking maybe about something else. Maybe, what if I want to see, this is, I didn't want to do anything like this, but what if I want to see, I'm going to throw a wrench in here. I'm not going to ask you to do it. But what if I want to see, for instance, revenue, the money that you collect, the revenue by product instead? That's a little trickier, right? In order for you to do that, you need to know that there is another function different from count called sum, right? You can use the sum function, another aggregation function. So instead of using this, we're not going to use that. We're going to use sum instead. So if I want to see the revenue by product, and you can mix them both, you can have the count and also the revenue, but I want to, let's simplify it, but say, you know how to do the count, let me show you how to do the sum, and then you can just combine them. It's okay. You can just keep that there. Here's the thing though. Do we have all the information? Let's say that we want to call this revenue. Something here, sum of something here. I don't know what that is, right? Sum of something here as revenue. Now we need to go back and figure out what is that we're summing here as revenue. Okay. So where can we find our revenue? Let's see. We have the product ID. Let's take a quick look at the information that we have. For the order details, we have the quantity. All right, so we have the quantity on the order details. That's good. But we don't have the price, though, so we can't really calculate how much money we made. Let's take a quick look at the products table, though. So we have the price on the products table, and we have the quantity order on the order details. We can do something with that, right? Does that work? Maybe? Before I continue that, can I re-explain the group by one? It works the same as order by one. So basically this is saying these fields that we have listed here, now we have three, right? This is the ordinal value of them. So this is going to be product number one. This is the field number one, number two, and then comma number three. So I'm saying basically the same as doing this. Like so. I'm saying organize it by the first field, product name. I mean, group it by the first field. And then organize it by sold. We good, David? Just the position on the field list. Another way of saying it. Preference for me, it would be this. I remember that when I added, I said just to show that you could use the number. Let me do that. But I like this because that now I have the flexibility of changing the order of these things. And when we were talking about this on the context of order by, I said if it's a small query, you could get away with saying order by 1, 2. But in a larger query, and you could have large queries, trust me. Later you come back and maybe change the order of this, and now you're grouping by a different thing. So having it explicit like this guarantee that you're always grouping by product name, no matter what it is. So what is sold coming from? We calculated that right here, over here, right? Because in this case, we cared about the quantity. Actually, I'm going to remove it right after this because I want to concentrate on the sum now, and this is going to get on the way. But this is where we calculate that. If you do that join without grouping or the count, right, you will get a number of records for the same product name. So this is just counting those records. So he said, what if I omit the group by? Well, it's going to count everything. It's going to give you one product name. And this is an artifact of the SQLite engine, I guess. Some database management system will tell you, hey, you're giving me a product name and account. This is an aggregate function. You need to group it. So you shouldn't even get a result. You should get an error when you're doing things like that. But yeah, it happens. So make sure that when you have like a field like that, like a column name and an aggregate function, you should group by. Again, if the aliases are confusing, don't use them. You don't have to. You can just say products here so everything makes sense to you. It's optional. Don't let that get on the way. If it's getting on the way, tell me and I will just remove them and just use the full name of the table. So let's tackle that, right? We said we want to sum something here, right? And we know that if we're calculating this by hand, we want to sum the quantity multiplied by the price. So we could do that. We could say, where's the quantity coming from? From here. So I want to multiply the quantity here, multiply that, and then the price that's coming from the product. So price. So we multiply that. And then let me remove this to make it simpler so you know only one thing at a time, right? So instead of count, I'm using sum. Calculate this value first, and then the aggregate engine is going to do that for us. The database is going to multiply that, and then sum it all up, group it by product name, and give us the results. That's what I hope to see. Let's run and see what we get. We have some column, something error somewhere. P the price, OD the quantity, P the product name. Sold. That doesn't exist anymore. So it will be revenue, I guess. Removed it, but left it. There you go. Here we go. Yeah, so equivalent to products. Okay, let's copy this. So this, and we can get rid of that. There we go. Product name, and then we have order details in place of this. And we're living the good life now of not dealing with the aliases. Because anything that makes it confusing for me, this is the place where bugs go to hide. Remember that. Complexity. Remove it. Get it out of your way. Run it, and we should get the same results. Cool, cool. Another piece of SQL for you. And we're going to stop there with the sequels for today. We can continue doing this. This is fun, like solving little puzzles like that. It's kind of fun. And the thinking is normally the same way. You know, what can I do? Let's tackle one little piece at a time, and then I put them together in order, and that's it. We're done. Yeah. It's the same as when we're explaining the fields. As is the proper way of doing it because some engines will demand it. I think most of them now support just having a space. So it's the same rules that we use for the field names. Just remember that I said you could do that or just do this, and they both work the same. But it's a good way to have this as here to give you kind of a visual cue that this is going to be an alias for that operation on the left, but it's not required in most places. Good job. Good question, Jamie. So the question is, when would be a good idea to, David, by the way, on your question, I said it's an artifact of the way that the engine works this without the group by, but you should always use the group by when you're doing aggregations like that. Don't forget. So can you briefly touch on when you would want to run logic on the back end versus the front end? Yeah, it's an old age question of, there's this pendulum, right? When it comes to working, how do you divide the load in systems? And if you were old enough like me, you would have lived a few swings of that pendulum. When I started back in the COBOL days and stuff, you would do everything, well, before my time, because I didn't get to do a lot of that, we had a thing called mainframes, right? And at that time, you would have what we call a DOM terminal, a terminal that would just be good enough to kind of connect, has a keyboard and a screen, and that's it. No processor, no computers, no personal computers. So you had that terminal, and all processing happened on the server. And then Microsoft came along, and they say, well, the PC is king now. We should have those PCs, and we have, 286 and 386 and 486, and we have Turbo, and we have Pentiums. You can offload a lot of that processing that you have on that, $500,000 machine and buy cheap servers now, because you could bring the processing to the front end. And that was the time of like rich clients, okay? Rich clients where you have Windows and you have databases, Access, and you have DB, what do you call this? DB, I don't remember the name of it. And then Fox Pro and Delphi and Visual Basic systems, and they will run, you install those on Windows or on Linux locally, right? Or on Mac. And it's a native app. And a lot of the data was, so what would happen is you would have a database, get the data through the network to the client will process that, and then make whatever decision and send data back to the server. So we went from everything done on the server to the client processing, take a lot of the load. And then, by the way, now we're transferring a lot of data over the network. And as our systems started to handle a lot more data, if you're processing payroll for 20 employees, it's fine to get the data for the 20 employees and process that on your Delphi application, your Visual Basic application. But what if you have 20,000 employees? Do you really want to send that over the network? And that problem became evident when we moved from having computers on a network, connecting, internally network, into building web applications. And we started moving from websites to web applications. So the pendulum swings again. And we say, no, on a web application, the network is, 250. No, well, it was 56K, 33K only. There were no megabits. It was like 33 kilobits, the speed. So if we're doing that over a really slow connection on the network, we don't want to send those 2,000 records. We need to process that on the server. It's got to be done on the server. And then you only send the final result to the client to save bandwidth. Okay? All of these long conversations, so you know where I'm coming from. When I tell you, I don't know what the answer is, but depends. So we did that, and we have the PHPs, and we have the ASP classics, and all of those frameworks, Ruby on Rails, that we do a lot of processing on the back end, and then you will reload a page every time, right? And then later someone said, that's not a good user experience. We have these networks that are really, really powerful. I mean, we used to run applications on a 10 megabit hub. Now we have 100 megabit connection, so we can go back again and swing the pendulum to the other side, send a whole bunch of JavaScript, have React on the client, do a lot of processing of this, so that you can have a nicer user experience without having to go back and forward between the server and the client. And now we send the whole application and a lot of data to the client. So we have been back and forward in this. Where do I do most of my processing? I would say we are at a good spot now where The answer to that is depends. Your system may benefit, like that example that I'm saying, if you're calculating benefits for employees, maybe you want to process that on the database level, not even in your API, on your database level, and have stored procedures saved in there, because the database is going to be really, really fast to do that, and just send back the results to your client. So your database administrator is going to tell you, this process that you're running is hitting my database, running queries against the database, and then coming back down and doing inserts on the database over the network, and it's slowing down the database. I'm going to write store procedure for this, and everything is going to happen in the database engine without having to touch the network. Send me a command, order me, like you call a function, order me what you want to do, give me the data that I need and the parameters that I need. I'm going to process this on the server and just send you the results. Don't premature optimize, but any long-running process that is going to need to handle a lot of data should happen at the database level, should happen on a store procedure or a function. That's my recommendation. Even though some developers may not like it, that's the truth. It might force you to having to learn how to write your logic in SQL, but it's not as hard as you think. It looks a lot like the languages that you use, only with a simpler, cleaner syntax that reads like English. Pagination logic, you write your code on the client to assemble the parameters that you need, how many pages and all that, and then all of that are going to be part of your query. If you notice there, we're doing pagination right now. We're saying, what is the page size limit? So you establish that somewhere. Maybe you give it a default on the database, and you do that. You read those parameters on your API, and then when you assemble your query, you just pass that data to the database, and the database does the paging and send you back only the result that applies to that. So when you do order by limit, you're basically paging, right? The other portion of the limit is, what if I want page 3? Well, it's called offset. I could say offset 2, meaning I'm not going to see those two. You see 146.20. The next that you'll see, if I do that, that means I took 2 pages off. I'm moving. You could think of offset as your if you look at the floor, you have like, what do you call those square things on the floor? What would they call? Tiles, right? So if you look at the floor, you're standing on a tile, the offset would be, if I need to move 2, that means I move 2 tiles away. And wherever you land, that would be the page number that you are. So offset 2 means page 3 actually. Yeah. So if I do this, I'm paging now at the database level. This is the correct place to do that. You don't get all the records and page it on the client, on the API. And I can tell you right now, we're gonna be rushed into the migrations portion. This is really cool, and I think I should have a different lecture for this. Probably should do this some other day. It's a learning experience. Never had a group so excited about SQL like this. So yeah. Let's stop it here. Let me give you this last version of this, and I promise if you want to continue to talk about this, we could do that tomorrow for sure, do more queries. But I want to move into our API so that we could do some stuff, right? I don't remember where we were yesterday. Strong words have been said on Slack about who's the best cohort. What's the best cohort? I think we were working on Rolex, right? Yesterday. This is our exercise. I'm going to continue working on Rolex. Okay. But I'm going to do something drastic today. Should we take 5 minutes and then come back? Or 3 minutes, maybe. Quick break. Just to kind of break the class. And no, yeah, let's take Let's take a little less. Let's say 3 minutes, just to break it up and say we're going to be in JavaScript mode now. Stretch our legs. Yay. See you in 3. All right, welcome back. So we're going to use Connect's migrations to build a schema. What does that mean? Well, it means we're going to be visiting the schema portion of the Connect's documentation down here. Okay. What is a schema again? When I say schema, what do I mean? Yeah, kind of the layout, the structure, the definition of how our database structure is built. For the tables, the table schema means the properties and the data types and all that we need in order to have our table work. So let's take a quick peek at what we had yesterday. We created a table called roles, and we call that table roles precisely, right? And the columns that we had is ID and name. And the name is a string. And the ID, if we go look at the structure, we can see it here. It's going to be a varchar, represented in JavaScript as a string, right? This is just the equivalent on the database level. And then the other one is an integer. It happens to be the primary key. They're both not null, and we want the name to be unique. Keeping that in our minds, I'm going to do something drastic here. Very drastic. I'm going to delete this database. The schematics, yeah, that's a good way of looking at it. So first, I'm going to remove it from here. So I'm right-click on the Rolex database. I'm going to say remove the database. I'm not deleting it. I'm just removing it from this tool so that I don't have this tool locking the database file as open. Okay, so we got rid of that. I removed it from there. And now I'm going to remove it from here. Ouch. So if we go and say reveal in Finder, I'm going to the data folder for this. We'll see that this data folder is now empty inside of our Rolex project. This right here, right? Am I looking at the right folder? Let's see. Data MD. If we go back in here, we'll see that we have that data MD right there. If I delete it from here, move to trash, it's gone from here. So this is empty. There is no database there now anymore. So what we're going to do is we're going to use connects to generate that and define the way that the tables inside the database look. Okay? Yeah. Reveal in Finder in Windows is called Reveal in Explorer. That's what it does. So you click somewhere in here and say Reveal in Finder or Explorer. I don't know about Linux. Never done in Linux. Okay. So for that, we're going to use connects. And again, we're going to be on the schema portion. So when you're looking at what to do, let's say that you want to drop a column. Remember, dropping means deleting something. So if you're dropping a column or you want to rename a column, you would look into the schema builder section of this. So if I'm creating a table, there is a create table right there. So this is the stuff that I'm going to use. I want to call your attention, though. The documentation has it this way. They don't really tell you the whole story. Actually, when you use it, you'll see that you need to return this call. So it will look similar to this, but you're going to do return connect schema.create table. But I'll show you, don't worry. So let's go in here and say, all right, one thing is what is the way that we create a migration on using Kinect, when using Kinect? And what is a migration? A migration is a way for you to record changes to the schema of your database in a JavaScript representation of that. So I'm going to create one, and then we'll talk about it. So I'm going to say, I'm not going to do Kinect in it yet, but I will in a minute. I'm going to say npx connects next, right? Just by doing npx next means I don't have to install it globally. And it's telling me, hey, you have to give me more information. I don't know what to do. But there is some information in here that is useful, okay? Because you'll see that the commands that you can use are basically 3 down here. Init, migrate, or seed. Those are the 3 things that you could do with this tool. So we want to work with migrations first, and then we're going to come back and do the init properly, the way that it's supposed to be. But the migrate has 4 options, actually. So we don't care about the last one, but we care about the first 3. Make is going to let me create a name migration file, a JavaScript file for the migration. Latest means apply those changes to the database, and rollback means undo the last set of migrations that you applied to the database. So let's concentrate today on the make portion of this. So I'm going to say npx next migrate make, and then I'm going to give it a name. See, you have some options. The options here would be things like I need to pass the configuration, an object with the, the information about the configuration, so that Kinect, I'm going to continue to call it Kinect, I'm sorry. So Kinect knows how to connect to the database. What is the name of the database file? What driver to use? We have that, but we have it in our code. Kinect has no access to that. So if I try to do this, something like bootstrap the database, it's going to tell me no local install. I don't have it locally. This is now complaining because I don't have it on my project here, on the package.json is not there yet. It is. So am I not on the right folder? Why are you telling me that? That's not the right error. The thing is that we don't have the options for this, right? We don't have a place for Kinect to go and find the options to configure itself the same way that we're doing it here. The way that we generate that, we could generate like a starting file. You could just write it, but there's a better way. npm connects. Oh, by the way, I think I know why I'm getting that error is because I removed the packages to send you a lighter version of this. That's why I'm looking. Why is it giving me that error? Okay, that's it. So let's try it again. We should get a different error now. That's what I expect. It's like, I can't find the documentation. I can't find that object to configure this. Now let's do npx connects init. No colon, just init. That's the first command that we're going to run. And this created a connects file in this directory. So if we go to open that file, here it is, right there for free. It's like creating a package.json with npm init. Same thing. And this is just an object that's going to look a lot, really a lot like what we have before in our index. I have this configuration object, only that we have 3 of those for free. Pay attention. This is a really critical step. I'm going to delete those 2 because I'm not going to use it for now. Not really critical, but it's going to be critical because that means that we can clean this up. Okay. So I know in a minute later, someone is going to come and ask me, where's the rest of the configuration? The answer is I deleted it. And I'm keeping only this object, only the development version. This is the one that's going to be used by default. Okay. Now, look at this. Client connection with the file name. It's missing this. Let's go add that there, right? Because I know we need that for SQLite. Save that. Now, this is exactly the same object, same configuration. Well, not really. We need to change this. So you don't have to do this by hand. You can just do connects in it. This is how you're going to do it from now on, probably. And then you configure your development, your staging, your production environments there. What would happen is on Heroku, it's going to use the production configuration. So you can configure that to use something like Postgres. We will do that together so that you see how it's done. But for development, we're going to continue working with SQLite and our database. But you would say, Luis, this database does not exist. Connect doesn't care. It's going to create it if it's not there. It's going to say, do I find this? If it's not, I'm just going to create it whenever I run that migration. So let's go into the next step. All right, so let's see if we can create a migration now. Cool, run it. Again, the same command, npx connects migrate make, and give it a name of bootstrap. Do that, and there should be a migrations folder showing up here. And this is going to record all of our migrations. We can choose where to place that in. You could see that on the example that I have. You just pass an object for this, but we're going to keep it simple today. Okay. Now, it created this file, and this has a timestamp, and the reason for that is migrations needs to be run in order. Okay. It's important. So the tool is going to guarantee that this is the first migration that runs, and as we add more migrations, they're going to be executed in the same order that were created because of this timestamp. So a migration has 2 parts. Don't worry, I'm going to let you do it. Please ask questions as I work through those. A migration has 2 parts. The first one answers the question, what changes are to be applied to the database? And then the second one says, how can I undo the changes? It's like having undo for your database structure, not the data, remember, not the data, but the structure of the database. Okay, kind of a rollback, that's correct, but for the structure instead of the data. Very good. So the way that this works is, you're going to take that code that you see in the documentation and you're going to stick that return in here. You're going to say return, call to the schema section of this. And the command that we want to create a table is called create table. Remember that you have ways to drop a column, to drop a table. A lot of commands related to manipulating the schema of your database. create a table, and this is going to take the name of the table. We call it roles, and then a function that could be an arrow function. It's a regular function that is going to get an object, and this object represents the table that you're creating. You're going to use these objects to define all the changes that you want to apply. So I know that we want a primary key called ID. This is so common that by just calling TBL increments, it will generate by default called ID integer auto increments. The auto increment is the name that you have in SQLite. This is called a serial in Postgres. It's called a I don't remember, identity field in SQL Server. Connects is going to take care of that. It's going to translate that into the proper data type, and it's going to configure it for you to auto increment depending on the client that you're using, on the database engine you're using. So we get that for free just by doing that, increments. Now, the other field that we wanted was something that is going to be of type string. So we're going to define it as a string, and it's going to translate that into a varchar for us on the database. And then the name of that is, I think it was name, and we gave it a sizing of 128. Again, SQLite is going to ignore the sizing, again, because they want it to be lightweight, but databases, other databases will respect that. And we want this to be not nullable. And this translates into making it not null at the database level. Information that we can get for free is like when it was created and it was updated, you can just do this and get that. You could say timestamps with an S. And then you pass true and true as options, like do you want to make the default of the current date? And the other one is like, I don't remember what it is, but you pass true and true, and you will get 2 fields for free. I'm going to show you on the results. Here's the beauty of this, and I know you cannot see the value now. But let's say that we create this table. But then in about 2 years, we need to add another field here, another field. Turns out that the version of the software, when you download that repository today and you run the migrations, is going to generate a database without this another field. Why? Because our system was created against a particular version of the database schema. But then in 2 years, your code is looking for that field, and if you run it against a database that doesn't have it, it's going to break. But do not despair, because every time you make any change to the database on the future, in 2 years, you don't come and modify this migration. You just make another one. So every change that happens to your database is going to be aligned perfectly to the changes that you have in your code base. So your software is looking for a particular version of the database, and they're going to go together. If you continue as a good practice, making migrations for every change you do to the database. Because at some point, all you have to do is say, I want a database the way that it was when I download, when this version of my software was committed to the repository. All you do is one command, run the migrations, done, database configured correctly for that version of your software. I cannot begin to explain what this means, right? Working without this in the past, you have no idea what the things that you had to do to make sure that those two things kept in sync. This is so easy that we don't see the value now because it's so easy. Just the schema. That's a good question. The data, no, not the data, the schemas, right? This is about the structure of your database. The data is handled by backups and things like that. So you do a backup of the data and then you restore it later. This is about the structure. And the structure is actually what breaks our software the most, not necessarily the data, even though it has some bearing in that too. Okay, so I say that these are the changes that I'm going to apply to the database. How can I undo those changes? If I create a table, what would be the opposite of that? Again, don't forget that return. It's not going to be on the documentation, but you need it. It would be to drop a table, right? So you can say drop table. And I like using one that says if exists, so that the command doesn't even run if the table doesn't exist, but you could use drop table. Roles, that's what I care about. I want to drop that table. That's it. That, boom. Now I have that migration. I have my connects is going to be able to look to find that development option. That's what it's going to look for by default on development. Unless you pass it, you say, I want to use a different environment. It's going to use this one. So we're going to rely on that being called development like that. It's going to connect, create this file, and add a table inside. That's what I hope is going to happen. So this is drop table if exists with an S. Thank you, sir, for catching that. Then here, how do I run it? Well, npx connects migrate latest. This is like update my database. Oh, look, it ran successfully. So I should have the database file now again here. Let's refresh that. Oh, look at it right there. And if we go and open that again, in SQLite Studio, let's go bring it in, open it, open folder, RolexDB, open it. Okay. Double click on it. Look at the tables. We have the migrations and we have this roles thing. Again, this roles table now has the structure that we expected. And we get this, these two fields come from where? Those datetime fields. The timestamps true. That's correct. It gave us those two fields. Oh, wait, I wanted to make this unique. Oof, I need to change that because now I see that people are repeating the roles and I want this to be unique. Well, if it's in the beginning like that, it's fine to go on, you know, just roll back, say, hey, and I could get away with this because I'm just starting out, but that's not the way that you do. What you should do when you're going to make a change like that, you should do what? What should I be doing? What's the proper way of handling this? Create a brand new migration. But I wanted to show you how to roll it back, so I'm going to do it this way now. So I'm going to say, I want to roll back that change. npx connects migrate rollback. Okay, so it undid the changes supposedly. So if we go and refresh here, refresh all database schemas. Oh, look, no tables. It's gone. You have the migrations, but you don't have my roles table anymore. Okay, so this is wrong now. There's nothing there. Let me close all that. No table. So again, I could now take advantage of that and say, hey, I want this this thing to be unique. And there's different ways of doing this. I could just say unique here. And that will make it unique. It's going to create a unique constraint and it's going to create the index for that. And that works. Another way of doing it is extracting it out and defining the unique index separately. Oh, you're just going to add it here because it's simple to do that. But if you see syntax where you have this be defined down here like so, you know, a unique, then it's going to ask you which field you want to be unique. It would be the name field. That corresponds to this name right here. And there's a second argument you can pass and you could give it a name. You could say, oh, I want this to be the unique index. Unique name, role name, let's say, role name. But that is optional. If not, it's just going to generate out one automatically for you. So normally you don't care about that. So we're going to leave it as the simplest version, which is on this file, I want it to be unique, not nullable and unique. Save that. I don't know, this is a migration that changed. So if I run it again to latest, the table that gets generated is going to have, it's going to take that into account. So let's refresh this. Look at the roles table now. Double click on it. Look at the structure. And it's not marked here, but trust me, it should be unique. It's probably a UI thing. I don't know why it's not showing. I always get that. I don't know why. It should have been marked. I don't know why it's not. I'm gonna leave it as a tool because this works. What am I getting this from? Well, if you go look at the chainable methods right here, there's a unique method right there that says if you have the table, you could do unique columns and all that, but you can also mark it somewhere in there. They have, I don't know what it is. Oh man, somewhere in there they show that the chainable you could call it on a column, on any column. So there's an example of it. And they show here the other way of doing it, where you say table.unique and then pass the value. Now I want to find the chainable to give you an example of it. Unique. They don't have it here. Oh, wow. Same with the index. You could define it this way, but you can also just chain it. This is important. I want you to see it. If you can find, there it is. You could do it this way, right? So this is the syntax that we're actually using. But we already have the column defined. So instead of calling it on the table object, like you saw in the other example, you call it on the column at the end and just call unique. That's the syntax that we're using. And it works, okay? It's gonna work. So that's it. That's the basics of it. I don't want to go too far with this, but when you're creating a table, you're going to return connect schema create table, passing the configuration for the table, and looking at the schema, you're going to see the different types, how they're defined, that you need, and connect is going to do the right thing. It's going to translate that. The timestamps will give you those two free fields. Is that something that you care about? And in theory, I should be able to do yarn server because the database is already there. And if we go back and test our code, like we did yesterday, look for roles, we have that beautiful square brackets because we haven't posted anything yet. So let's do a post to that. Send some roles. Record that value exit. Oh, what is this? That's not true. Did we? Oh, this is empty. Sorry. Name, and then we're gonna pass this as admin. Send that, and we should get back our first record. So we go check our collection now. We have data. So everything is working because the database was generated following our instructions. Okay, we're not going to have enough time to talk about foreign keys today. So any portion of the exercise that talks about foreign keys, consider that to be a stretch. So if you can do it, if not, just concentrate on doing the other stuff, just to sync the tables that you need to create. So for the project today, let me kind of do a quick walkthrough of this, make sure that we have some of it covered, right? It would be this project right here. Your job is to create cohorts and students. Okay, cohorts and students. And of course, you have those endpoints that you want to continue to flex your muscles on that. Stretch problem is to add those. There is a reference here. Let's introduce it real quick so you have an idea of the syntax and how it works, and that way you can complete the exercise. And then tomorrow, as we talk about data modeling, this is where we go deeper into how this works. Sounds like a good plan? Okay. So you have a sample of how to do the reference. So let's say that I wanted to create another table. Okay, I could just chain that there, but let's go and create another migration. Let's do it the right way. Create another table. And that's going to be called users. Let's call it users. So npx connects migrate make users. I think it could be the users table if you want to be a little more explicit. gonna borrow some code from this, of course, of course. This always goes bad when you do copy and paste, but let's give it a try. I'm gonna call this users instead. So users, it's gonna have an ID, it's gonna have a name, not nullable, it's gonna be not unique. We don't want that to be unique. It's a name, so for user, maybe repeat it. And the timestamps, that's good. And we want to drop it if it exists. Okay, but I want these users to be assigned a role. So a role can have many users in our schema the way that is defined now. Okay, so here we go and define that. So I'm gonna say TBL, and the type is gonna be an integer because that's what that increments generates automatically. So it's gonna be an integer. We're gonna give it a name. Let's call it role ID, or it could be role ID, like that, role ID. And then there are different ways of doing this. There is a foreign that you could call. I like another one that is called references. And by the way, make this unsigned because some databases want this to be unsigned. So as a default, every time you're doing a foreign key, just default to having an integer unsigned. That's a good default. Now, I'm going to pick the one that says references because I like thinking of this as referencing a primary key on the other table. So references, the ID in table roles. Tell me that's not a beautiful syntax. There are some options that you could set on this. One of them is called on delete. And this answers the question. We'll talk about those tomorrow, but for now, make them cascade so that you don't run into issues. Make it simple for you, but we never do that on cascade. And on the other one is on update. That we want to be cascade all the time. There are different options for this, but we go into data model tomorrow and then we'll know what they mean. For now, just use this and follow that example on faith. This is going to let you create a reference pointing to the ID field on the roles table. And this is the name of that field in this table that we're creating here. So how do I run it again? What can I execute to run this? What can I run? Instead of make, now it's going to be migrate latest, right? Oh, this is not there. Migrate latest, like so. Okay. Now, the question for you is it going to run both? Because we already have the bootstrap and also have this. Is it going to run them both in order? And the answer is no. You might remember that there is this connects migrations table here that is kept for us by connects, right? And this remembers what migrations you have run. So if you go look at the data, it's going to say, hey, I already ran the bootstrap, so I don't need to run it again. And I run it as part of a batch. This batch means that I could have 5 migrations created and they all run together and they get rolled back together, right? I like having my batches of one so that I could run one migration at a time. But know that if you create 2 or 3 migrations and then you run later, it's going to run all 3 as part of the same batch. And they always get undone together. So a good practice to avoid that is to have more granularity is you create a migration and you run it, create another, you run it, create another, you run it, so that you can roll them back one at a time. Because it works like undo, right? You add something in your code and you undo the last thing that you added. So it's the same thing here. It's going to undo one batch at a time. So connects knows through this table that it already ran that migration, so it's not going to run it again. It just runs the last one that is brand new. So when we do that, we ran one migration, and if we go back to our table now and refresh, is it F5? I don't remember what that is, but just read it. Now we see that we run 2 migrations in 2 different batches, which is awesome. Okay, so now our table should exist. If I refresh all the data there, we have the roles, but we also have the users with some columns in there. So if you double click on that, See the structure of the table. I'm looking at, what am I looking at? Not condensed migrations. I want to see the other table. This one. There you go. We have the role ID, which is an integer. It's got a foreign key defined. You can see that there. Okay. And that foreign key is a constraint that it's pointing. Look at the foreign key right there. The foreign key constraint is pointing to, is the role ID, references the role's ID, and has the on delete and on update. So rush through it. I'm going to give you the code. And that should get you started. And then we'll continue working on that tomorrow. So you'll be okay. Tomorrow we'll mention seeding. I don't think we have seeding on the project, so it's okay. Let me see if we have to seed data. Oof, you do have to. But this takes a minute, I promise. This is really, really, really easy. All you have to do is say, hey, Connects, instead of migrate, I want to do seed, make, and give it a name. I normally give it a name with number, like 0001, 001, dash, so that they run in order. And I'm going to say, I want to seed the roles, okay? And I do different migrations for each table, different seeding, right? So if I want to seed also the users, I would do 002 users. This pretty much guarantees that they respect the foreign keys and they run in order, because I need to have a role before I have a user, right? And then users. So I'm basically, instead of having that timestamp, I'm controlling the order in which they run. So I'm going to do the roles, and then it's your job to do some users. So all we do here, we're going to come back. We're going to change this delete to truncate instead. And then tomorrow we're going to do something different with this. But for now, just do this. You truncate the table. This means delete all of the records and reset the IDs on the table. And then this, insert all the entries. You may notice that this is just a simple collection of objects. So if I know that all I'm using here is only the name, it's all I have to set for the role, I could just say each object has a name and give it some value. So it's going to seed this data with maybe student, PM, and TA. Those are the three roles that we have defined in this table. So connects, seed, column make, give it a name, and then change the data that you want to seed automatically into the table. Of course, you need to change the table name here to make sure that we're seeding the right table. So it's going to be for roles. Save that, and then we can run it. Look at this. I can say seed, run, and boom. Table name, it's not saved. Roles. Ah, I know why. It's the second seed, this second seed right there. I'm going to delete it because it's getting on my way. It's on the second one that's failing. So seed run, and that's it. It ran. That means that if I go now and refresh, we should have those three records for the roles. There they are, student, PM, and TA. And they got seeded automatically by Connects. Yeah, you can use Faker.js to generate some values and then just use seed to seed them, which is awesome. So in summary, we don't have to use SQLi Studio again. No. In summary, that means that you can do a lot of things from here, from your JavaScript code, and keep them in sync. But SQLi Studio is still useful, though. All right, so I'm going to stop it here because I went over time. Sorry about that. We just got excited on the querying stuff. And go ahead and work on the project. And then tomorrow we talk about data modeling. So we talk more about the other side of the join, which is how can I establish that using foreign keys like we're doing here. What does this on delete means? What does cascade? Are there other values? We're going to learn all about those. Is there a better way to do the seeding? Because you're going to run into issues when doing the same thing that I'm doing here with databases like SQLi, like Postgres or MySQL. you're going to run into an issue. I'm going to introduce a little library that I use for that. So far, it seems to work fine. It's an NPM module a lot of people use to deal with those problems. So a few gotchas that we have here, we're going to talk about tomorrow. And then hopefully you're going to walk away with having an idea of going from, I need to design a system that does this, to how can I design my database schema to accommodate that system. That's the conversation tomorrow. So, questions? Cool. So I'll see you on Slack. Good job and thanks for staying. So long.